Hello, everyone. Today, um, well, this video, I'm trying to do the combining random variables exercise. So let's dive in. Okay. Actually, I need my calculator as well. Right there. So now this exercise requires you to know what's going to happen to the mean and standard deviation when you combine random variables. Uh, so it's just the same application, right? You need to remember how to do that. This time, this one is going to be a little bit tricky because you are not just combining any random variables. You're combining normal random variables, and you're using it to find probability. So when we deal with normal distribution, all right, normal random variables, to find probability, you need to use the normal CDF. So everything is going to come together. So let's dive in. So a breakfast cereal producer makes its most popular product by combining just raisins and flakes in each box of cereal. The amount of flakes in the boxes of this cereal are normally distributed with a mean of 370 grams and a standard deviation of 24, right? So this is for the amount of flakes. Then the amount of raisins are also normally distributed with a mean of 170 grams and a standard deviation of 7 grams. So there are a few things I want to write, and I want you to kind of follow it if possible. All right. All right. So I need to erase this. Thank you very much. And so we have the flakes, right? So that let f be the random variable for the flakes. And random variable, it's normally distributed. So now we usually put an n, and then we put a bracket. 370 is the mean, standard deviation 24. And then the raisins, let r be the random variable for raisins. And then we put this curly line, and then n with a mean of 170. So this n says that it's normal. This n says that it's normal. Normal with what though? Normal with a mean of 170 and a standard deviation of 7. So here, T is the total amount of product in a randomly selected box. Now, this box has, amount of flakes and amount of raisins. And this is really important. They say that assume that the amount of flakes and raisins are independent. If it's not independent, you cannot do this question, right? There's not enough information for you to actually do this question accurately. So now define the probability that the amount of raisins exceeds 550. So let's kind of backtrack a little bit, okay? Um, when T, we know it's going to be F plus R, right? T is the amount of flakes plus the amount of raisins. Now we need to find mu of T, right? We need to find the mean of T, and mean of T is it's actually pretty easy. It's mean of F plus mean of R, right? And we did that in the previous exercise, so you need to go back and review if you don't understand this. So mean of F, which is 370, plus mean of raisins, which is 170, and that comes up to 540 grams. So the mean is 540 grams. Now, what is our standard deviation of T? What is our standard deviation of T? So remember earlier in the previous exercise, we say we do not add standard deviation, we do not subtract standard deviation. The only thing we can do is to add the variance, right? The variance is what we need to add. And there's a formula, right? We need to take, because variance, we know variance of T equals to variance of F right? Variance of F plus the variance of R, right? Variance of T right here plus the variance of F plus the variance of R. And we know variance. Variance of T is sigma T whole thing square. So to find sigma T, we have to undo the square. So we got to take the square root of it, right? Take the square root of. So what is the variance of F? Variance of F is you take the standard deviation and you square it. Plus, remember we can only add variance. Plus the standard deviation of resin and then we square it. So that will be the variance of R and the variance of F. So if you do a little bit of math, square root, so square root of 24 square plus 7 square, oh, that's 25. So this new distribution, right, T, this new random variable, right, this new random variable is also normal, right? It's also normal with a mean of 540 and a standard deviation of 25. So if you add 25, so it'll be 565. And add another 25, it'll be 590. And then add another 25, it'll be 615. And then so on and so forth, okay? Right? So it's going to be normal. This T, this new random variable T, which is what you get when you add the flakes and the raisins. Because both of them are normal. When you add those two normal random variable, your T will be normal too, right? So they ask us to find what's the probability that the total amount of product exceeds 515. Now, 515 is probably here on the left-hand side. I don't need to write all those numbers down. Maybe I should. So 540 minus 25, it'll be 515. And then 515 minus another 25 will be 490. Okay, I can stop here now because where is 515? 515 is right here. So 515, so this is 515. Okay, and they want us to find the probability that the amount exceeds 515. So we're going to shade it to the right. And this goes on to positive infinity. So ladies and gentlemen, in order to find the probability of a normal distribution, we need this thing called normal CDF, right? Where we need four things. 1, 2, 3, 4. First thing is your lower bound. So lower bound, it'll be best if you draw a graph like this because you can easily tell that the lower bound is 515, right? The shaded area, 515. The upper bound goes all the way to infinity. Now we do not have infinity on the calculator. The best thing to do is to really put a big number. And we need to put the mean here, mean of t. And didn't we find the mean of t is 545? Standard deviation of t is 25. So with that, we can put it into calculator. 515, 999, 540, 25. Okay, so hopefully I remember everything. Maybe I have to write this down. 515, 999, 540, 25. Okay, so we go to second verse, right, to find the normal CDF right here, number 2. Then it asks us for the lower, and we said that the lower was 515, and the upper was 9999, and the mean is 540, and the standard deviation is 25. So, ladies and gentlemen, the probability that the amount of product exceeds 515 grams, round to 2 decimal place, is 0.8. Hallelujah. Okay, so next question. So Ali and Bruno both run the 400-meter dash for their track team. their coach frequently records their finishing times in seconds, which are summarized in the table below. So they summarize it below, right? So the mean time for Ali. So both are random numbers, right? Sorry, random variables. Ali is a random variable, A, mean 59, standard deviation 4.8. Bruno is a random variable, B, mean 50, standard deviation 3.6. Both distributions are approximately normal. Now that is important because when we add or subtract those or combine those random variables, we know that the final distribution will also be approximately normal. Then we can use our normal CDF to calculate the probabilities. Suppose we choose a random 400-meter race, right? 400-meter race, and calculate the difference between their time. It's reasonable to assume that their times are independent. Now, this is huge, right? Without this statement that saying that times are independent, we cannot do this. So find the probability that Ali's finishing time is faster than Bruno's finishing time. Okay, so ladies and gentlemen, this is a bit tricky. So you want to find Ali's finishing time that is faster than Bruno's finishing time, right? So you're saying this. You're saying you want Ali's time to be less, right? To be less than, so to be less than Bruno's time, right? You want Ali's finishing time to be faster than Bruno's. So in order for Ali's time to be faster than Bruno's, Ali needs to have a lesser time, right? Lesser time compared to Bruno. So if you do the algebra here, so it's A minus B less than 0. Do you see now we can try to combine your variable A minus variable B. And you can actually let it be D, right? Let it be D. D is equals to A minus B because we now need to find the standard deviation of D, right? D is a new random variable that involves A minus B, which also means that the mean of D equals to mean of A minus mean of B. And mean of A is 59. So it's 59 minus mean of B is 50. So this is 9. So in a normal distribution, a new for a T random variable, sorry, not T, my bad, I must say, think too much of T. For D, right? So this normal distribution for this random variable D, which is A minus B, the mean is 9. Now we need to find the standard deviation of D, which is the square root of the square of this 4.8 square plus the square of this, the 3.6 square. Okay? All right? And if I can do this on my other calculator, 4.8 square plus 3.6 square. Oh, 6. How convenient. So the standard deviation is 6. That means 1, 2, 3. 1, 2, 3. So it will be 15 here, 21 here, 27 here. It will be 3 here, negative 3 here, negative 9 here. So this will be the normal distribution for D, right? For this new random variable D. So we are trying now to find the probability that D is less than 0 because we're trying to find, so here, see how A minus B, Ali's finishing time is faster than Bruno. So D is less than 0, right? D is less than, where is 0? 0 is probably about here. On this graph, D0 is about here. And we are shading it to the left, right? Shading to the left because it's less. Shading to the left, and then this goes on to negative infinity. So, right, with all this in mind, finding the probability will be normal CDF. I need 4 things, remember? Okay, first thing is the lower bound Second thing is the upper bound, right? The third thing is the mean and mean of D and then standard deviation of D. So the upper bound, sorry, the lower bound is going to negative infinity. So negative 99999. Upper bound is zero, right? Zero, because we wanted to find D is less than zero so that the finishing time of Ali is less than the finishing time of Bruno. So this will be zero. Standard deviation is 9. Sorry, mean is 9. Mean of D is 9. Standard deviation is 6. So, right? So I need to remember that sequence, and 0 and 9 and 6. So if I go to my calculator now, right? So second verse, number 2. My lower is negative. I need to use this negative. Negative 99999. And then the upper is 0. Mean is 9. Standard deviation is 6. So here, look. The probability of Ali faster than Bruno is 0.07. Round to the nearest two decimal places. 0.0, sorry. Okay, so I hope this makes sense. There's some questions that are really, really tricky. Um, I hope if you have any questions, please let me know. If not, good luck, and hope you can work hard. And let me know if there's anything I can help. Okay, thank you. Bye bye.